All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still inside our natural language module. Let's have a look at what we went over tonight. Now, tonight I thought we were going to be running some code, but it turns out that we still had to go over a few concepts before we can actually get there, so it's going to be another night of light reading. So let's pick up where we left off. Last night we left off with the bag of words, and we're going to pick up there. So the bag of words, as you recall, is a model that represents text as an unordered collection of words. For the purpose of this model, we're not going to worry about the sequence and the ordering of the words, which word came first, second, or third. We're just going to treat the text as a collection of words in no particular order. And we're losing information there because the order of words is important, and we'll get back to that a little bit later. But for now, to simplify our model, it will help us tremendously just to think about the text as some unordered collection of words. And in particular, we're going to use the bag of model. We're going to use the bag of words model to build something known as a naive Bayes classifier. So, what is a naive Bayes classifier? It's a tool that is going to allow us to classify text based on Bayes' rule. This is Bayes' rule here. It's the probability of B given A equals the probability of A given B multiplied by the probability of B divided by the probability of A. And we might remember this from when we talked about probabilities. Bayes' rule said that the probability of B given A is equal to the probability of A given B multiplied by the probability of B divided by the probability of A, as I just stated. So how are we going to use this rule to be able to analyze text? Well, what are we interested in? We're interested in the probability that a message has a positive sentiment and the probability that a message has a negative sentiment, which for simplicity, we're just going to represent as P and N. P means positive and N means negative. And so if we had a review, something like the Gates family really liked the service they got on a Disney cruise. It's all they talked about for a month straight. We're looking forward to going next year. Then what we're interested in is not just the probability that a message has a positive sentiment, but the conditional probability that a message has positive sentiment given that this is the message. So given that this is the message, the probability given the Gates family really liked the service that they got on the Disney cruise is all they talked about for a month straight. We're looking forward to going next year. How do we go about calculating this value? The probability that the message is positive given that the review is this sequence of words. Well, here's where the bag of words model comes in. Sorry about that. Rather than treat this review as a string of a concept, Rather than treat this review as a string of a sequence of words in order, we're just going to treat it as an unordered collection of words. That's why I'm going to leave it tonight, because it's just a bunch of more reading and going over exactly what we're going to be diving into before we start actually running the model. We did do some more in-depth scaling and some more in-depth modeling, but yeah, I'm not going to go into all of that tonight. But we will pick it up tomorrow, and of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.